Hello everyone, welcome to Diksha Karnataka YouTube channel and in Sankalp KCET 2026 series. Today I am going to discuss the KCET PYQs of the chapter Moving Charges and Magnetism. This is a very important chapter and up to 4 questions do come from this chapter almost every year. So if you watch this PYQ video as well as the 2-part videos that I have already completed, you can score those 4 questions in KCET. Not only that, it is also a very important question, important chapter for your PU board exam. So do check out the part 1 and part 2 of this chapter. Now let us continue with the PYQs of this chapter. First question is from 2025. Yes, we have included 2025 questions as well. So two thin long parallel wires separated by a distance small r from each other in vacuum carry a current I in ampere in opposite direction, then they will. So let us briefly draw the diagram. So we have very long wires, each of them are carrying current I. Okay, but they are carrying current I in the opposite direction. So what is the formula for they are separated by a distance r? What is the formula for the force between the charges? Force between the charges per unit length, force per unit length is given by small f is given by mu naught by 2 pi I1 I2 by distance d. This is the formula. Now in this case both I1 and I2 are equal, but the distance is given by r. So let me put that value, mu naught 2 pi I into I into I means I square by r. D is equals to r in this case. So the force per unit length is given by mu naught I square 2 pi r, mu naught I square by 2 pi r. So either option A or option D is correct. Now which is correct? So equal charges in same direction attract each other, charges current in same direction attract each other, current in the opposite direction repel each other. So in this case it will be repulsion. So repel each other with the force per unit length of mu naught I square by 2 pi r. So be careful. Whether it will be attraction or repulsion, generally in general we have seen that opposite charges attract, opposite poles of a magnet attract, but in case of current it is opposite currents repel, same current, same directional current attract each other. So this is something which is not common, so be careful about this part. A solenoid is 1 meter long and 4 centimeter in diameter. It has 5 layers of windings of 1000 turns each and carries a current 7 ampere. The magnetic field at the center of the solenoid is, so we have a solenoid, the diameter is given, but remember that in the formula of magnetic field diameter plays no role. So magnetic field is given by mu naught N I, that's it, nothing else, right? Now here we have to find the number of turns per unit length. You might think that okay, number of turns per unit length is 1000 in this case. Actually no, little bit be little bit more patient and read the question twice if required. The length is given 1 meter, which is very good, so we don't need to convert it. 1 meter means obviously meter per unit length means 1 meter length, right? So that's why it will be fine. But here it says 5 layers. What is the meaning of 5 layers? So this is 1 layer. We have one such more layer over here and another layer and another layer. So each of the layer has 1000 turns. So total number of turns per unit length is not 1000 but 5 times 1000, that is 5000. Okay, so 5000 is the number of turns per unit length. Length if you divide by 1 meter it will remain same, right? So per unit length, number of turns per unit length will still be 5000. Clear? Why so? 5 layers are there, each layer 1000 turns. So 5 layers, total number of turns 5000, the length is given 1 meter, so you have to divide by 1 meter. So divide by 1 meter does not change, 1 is good for us, so that's why 5000 meters, 5000 per meter is the number of turns, right, per unit length. Now what is the value of mu naught, which is very, very important. The value of mu naught is 4 pi into 10 to the power of minus 7. Remember this value, okay, 4 pi into 10 to the power of minus 7. Number of turns is 5000 and current is given by 7. Now because current is given 7, we will write pi not as 3.14 but a little bit more older version, that is 22 by 7. Even though it is not exact value, it is approximated value, but we will use this value instead of 3.14. Remember, pi is a irrational number. You cannot write it like 22 by 7, but this is the nearest rational number. Okay, now let's multiply and check the value. So b will be 4 into 5. 4 into 5 means 20. 4 into 5 means 20. 20 into 22. 20 into 22 will be 44 or 450. Okay, 440, sorry, 440. So 4, 22 and 5, we multiplied these numbers. Okay, so what happens to the rest of the numbers? 1, 2, 3 zeros are there and 10 to the power of minus 7 was there, so we can write this as 10 to the power of minus 4. Okay, minus 7 plus 3, which means minus 4. Now if you see the answers are given in 10 to the power of minus 2 value. So let me convert it into 10 to the power of 2 value, which is 4.4 into 10 to the power of minus 2. Because we are adding decimals, that means we are reducing 10 to the power of negative value, right? So 4.4 into 10 to the power of minus 2, which is exactly equals to this answer. So option A is correct in this case. So as you can see, the approximation that we have done is, instead of using 3.14, we have used 22 by 7, so that we can cancel it and our calculation becomes easier. So this is a calculation trick question. So if you apply this kind of tricks, okay, even if your answer does not match exactly, but it is very, very close to this value, right? So you have to remember such tricks. Two similar galvanometers are converted into an ammeter and a milliammeter. The shunt resistance of ammeter as compared to the shunt resistance of milliammeter will be. So now let us understand. Galvanometer current will remain same. Galvanometer current is basically constant. The only thing that you are doing is that you are allowing more current to pass through the shunt, or less current you are allowing it to pass through the shunt. So let us remember the diagram. So here we have galvanometer with resistance G and we have a shunt resistance of S, say. Now if the current that is coming into the circuit is I, this I we are measuring, not Ig. Ig is constant. Ig generally is very low, it is always in milliampere. Ig is always in milliampere. Rest of the current passes through the shunt resistance I minus Ig, right? So only thing that we are changing is this current I. Okay, I we are changing, not the Ig. Ig will remain constant, right? And in fact you can write Ig equals to shunt resistance divided by G plus S into I, right? This is the value. Now this I we are trying to measure, so I equals to G plus S by S into Ig. Now why we wrote it in the opposite sense? Because this is the current that we are measuring, the input current, right? Now let us check what will happen if we do something. Say one I is ampere, another is milliampere. So our question is the shunt resistance of the ammeter to the milliammeter, right? So ammeter will be first, milliammeter will be second, right? Now here Ig and G is constant, same galvanometer. Okay, so Ig and G are constant. So only thing that will change is the shunt resistance. So you can write this as G plus S ampere divided by S ampere into S milliampere divided by S G plus S milliampere. Okay, now if you ignore the value of G, you can see that basically does not make any sense, but you have to understand that ampere is greater than that of milliampere. Ampere is greater than that of milliampere, right? So in one sense you can write this as G by SA plus 1 divided by G by SM plus 1. Okay, now this value is greater than 1. Why this value is greater than 1? This value is greater than 1 because ampere is greater than milliampere. Ampere is greater than milliampere. Now you have to compare this. So G by SA plus 1 is greater than G by S milliampere plus 1. Why I have written it like that? That is beneficial for me to compare, that's it, right? So if you divide this G by SA and plus SA by SA, so SA by SA gives you 1. Now similarly if you take that down and do the same thing, you will get the same thing in the division, right? That's how we got it. So plus 1 gets cancelled, G gets cancelled, so you get 1 by SA. 1 by SA is greater than that of 1 by S milliampere, or SA is less than that of S milliampere, right? If you take inverse, the greater than less than sign inverted, so SA is less than that of S milliampere, so the shunt resistance of ammeter is less compared to that of the milliampere. Okay, a small simple calculation. If you do this, you will realize that this is the answer, right? And why we require this long calculation? Because there is this G is involved in here. Otherwise, if this is direct inverse relation, we could have easily figured that out, but to eliminate that G, we had to take this proper approach. There is a small understanding that because S coming in the division, this is the main force that is driving this. For that, higher the current, less is the shunt resistance. That is the normal idea, right? So higher the current, less is shunt resistance. Ammeter is smaller compared to ammeter, so ammeter will have smaller resistance compared to milliampere. This is also a basic fact you can remember. Now identify the correct statement. Correct. So whenever you see such questions, correct, incorrect, mark under this statement so that you don't make any mistake. A straight current carrying conductor has circular magnetic field lines around it. So a straight current carrying wire has circular magnetic field lines around it, which is the correct statement. Okay, this is the correct statement. Now let us check the other statement as well. The direction of magnetic field due to a current element is given by Fleming's left hand rule. It is not correct. The direction can be calculated using Biot-Savart's law or right hand rule. Okay. The magnetic field inside a solenoid is non-uniform. Magnetic field inside a solenoid is uniform, right? The field lines are parallel. That means it is an uniform magnetic field. A current carrying conductor produces an electric field around it. A current carrying conductor basically produces only a magnetic field, but electric field is almost negligible because a conductor itself still remain neutral even if it is carrying current. Okay, because a conductor generally consists of atoms. Atom consists electrons as well as protons. So even though it is carrying some electrons, electrically it still remains neutral. Electrically it still remains neutral. That's why electric field around a conductor is usually negligible, even though the electric field produced inside the conductor is not zero, and that electric field is responsible for the current to pass through the conductor, and that electric field can kill you if you touch the current carrying conductor thinking that okay, it is still electrically neutral, so I can touch it and I will survive. But you may die because of the electric field generated inside the conductor, which is very high. Around the conductor negligible. So even if there is an current passing through this monitor that you are watching this, I am safe because the electric field around this monitor is almost zero. Okay. Now next question, which of the following graphs represents the variation of magnetic field B with perpendicular distance r from an infinitely long straight conductor carrying current? So infinitely long straight current carrying conductor produces a magnetic field B, which is given by mu naught by 2 pi I by r, right? So magnetic field is inversely proportional to distance. So correct graph will be this one. This is the inversely proportional graph, right? So this graph is correct. Next, a moving electron produces only electric field, both electric and magnetic field, only magnetic field, neither electric nor magnetic field. A moving electron can produce both electric and magnetic field. Moving charge can produce electric and magnetic field. Now just before that I was saying that a current carrying conductor, the electric field produced around a current carrying conductor is almost negligible. Electron are also passing in a conductor. So what is the difference? The basic difference is that here we are talking about free electron. No other protons or any other atoms are involved in here. So this is a free electron. Free electron, free proton, when they are moving, they will produce not only magnetic field, electric field as well. Okay, because this is the basic property of charge, right? If there is a charge, it will not only produce electric field, it will also produce magnetic field if it is moving. Static charge only produce electric field. Moving charge will produce magnetic field, but the static electric charge electric field will still be present, right? So both electric and magnetic field will exist simultaneously. Here it is a free electron, whereas in a conductor there are other particles such as protons and neutrons are present, that nullifies the effect of electric field outside the conductor. That is the basic difference. Okay, in case of conductor, electric field is present inside the conductor but outside it is zero, but in case of moving charge, electric field and magnetic field both are present. That's why later on we will see that they can produce electromagnetic wave. A coil having 9 turns carrying a current produces magnetic field B1 at the center. Now the coil is rewounded into 3 turns carrying the same current, then the magnetic field at the center B2 is. So first let us understand what is the question is. We have a coil having number of turns n equals to 9. Total number of turns n equals to 9. So what is the magnetic field at the center of this coil? Magnetic field at the center of a coil is given by B is equal to mu naught by 2 I by R. So this is the basic formula. So this is the radius, suppose. Okay, this is the first time. Now here it will be Ni. Okay, why Ni? Because number of turns is important. Right, number of turns, more number of turns means more current. So Ni is the value. So here it will be mu naught by 2 9I by R. Now the same wire is now wounded into only 3 turns. So if you change the number of turns, what will happen is that you had a smaller number of turns, smaller radius, number of turns was more. Now if you open it and you make longer radius, then the number of turns will be reduced, right? That is only way to reduce the number of turns. So here say it is R, now it is say R dash. Number of turns will be reduced if you increase the radius, right? But what will remain constant? The thing that will remain constant is the total length of the coil. So if you open it and if you measure the total length of the coil will still be constant, right? You are changing the only number of turns, right? Total length will remain constant. So what is the total length over here? Total length over here is basically 2 pi R is the perimeter times total number of turns, that is 9. So this is the total length at the beginning. total length at the beginning 2 pi r times the number of turns. Now what is the total length now? This should be equals to 2 pi r dash, that is the perimeter of one turn, times total number of turns, that is 3, right? So that's how you can calculate the new radius, that is r dash. So r dash is nothing but 3r. So r dash equals to 3r. R dash equals to 3r. Now you have to put that value over here. This is B1, this was B1. Now what is B2? B2 will be mu naught by 2, mu naught by 2, number of turns into current divided by new radius. So what is that? Mu naught by 2, number of turns is 3 now, and radius is also 3r. So 3 cancels and you get mu naught by 2 I by r. So as you can see, the magnetic field decreases, and if you see that this is decreased by 9 times. So B2 equals to B1 by 9. B2 equals to B1 by 9. So if you divide this by 9, you get this answer, right? So it will be B1 by 9. Option A is correct. A particle of specific charge Q by m equals to pi c kg per kg, pi coulomb per kg is projected from the origin towards positive x-axis with the velocity 10 meter per second in an uniform magnetic field B equals to minus 2k Tesla. The velocity v of the particle after time t equals to 1 by 12 second will be. So very interesting question. Here we have a particle. This is x-axis. This is y-axis. So when you try to project one and the magnetic field is negative means towards, so this is the direction of magnetic field. Magnetic field is into the page of the paper. It is into the page of the paper. So when you project a particle in the x direction, what will happen? It will rotate in a circular motion. It will rotate in a circular motion. The direction of velocity, initial velocity, and the magnetic field, they are perpendicular. So perpendicular means there will be a circular motion, right? And after some time 1 by 12 second, it will reach some angle, say theta. It will reach some angle, say theta. So from there, if this is v, okay, the magnitude of the velocity will remain same. Magnitude of the velocity will remain same. Only thing that will change, because initially it was launched along the x-axis, its direction will change. So if this angle is theta, then the new velocity can be written as the original velocity magnitude, which is 10 meter per second, times cos theta I cap plus sin theta j cap. If you see that magnitude, you will remain same. Magnitude means I cap square plus j cap square, right? Coefficient of I cap square plus j cap square, square root. So cos square theta plus sin square theta, square root will remain 1. So that's why it magnitude wise it will remain the same value. Okay. Now you have to find this value of theta. Now if you know that after some time, capital T, which is called the time period of the motion, the particle, my diagram is partially incorrect. My diagram is partially incorrect. Why? Because it will rotate like this. Okay. So even though it is initially launched like this, it will rotate like this. That's why this angle is theta. It will rotate in a complete circle. But the magnitude of the velocity will remain same. So if you are coming here with some technical mistake, so time period 2 pi is given, time period is given by 2 pi by omega, which is 2 pi m by qb. Okay, we have done this derivation, we have studied this answer as well, right? So time period is given by 2 pi m by qb. You have to remember this value Okay, or if you get time you can derive it as well, but in the exam you don't get the time to derive all such equations. That's why it is better to remember such values. Now time period is 2 pi by m by qb. Now q by m value is given by pi, so q by m is value is given by pi, so 2 pi divided by q by m b. Right, I have taken this m in the division, so it will be division of division. So now let's put the values. Magnitude only 2 pi into pi, and the magnitude of magnetic field is 2, right, 2 kt, k Tesla, 2 k Tesla, k is 1, the magnitude of k is 1, so pi cancels, 2 cancels, you get 1 second. So the total time period is 1 second. Now what is the meaning of time period? Time period means it takes 1 second to complete one rotation, 1 second to complete one complete rotation. But here the time is given 1 by 12 second. Time is given 1 by 12 seconds. So if that is the time, so what is the angle then? In one complete rotation, what is the angle? In one complete rotation, the angle is pi plus pi. Pi plus pi, that is 2 pi, right? But in the given time, the time 1 by 12 second, the angle will be, corresponding angle will be 2 pi divided times the time period, that is 12 seconds, into 1 second. 1 second is, it will be in the division. The formula is theta equals to 2 pi small t by capital T. Okay, now time period is 1 second, that's why this capital T becomes insignificant here, only the time is important, so it will be pi by 6. Pi by 6 means 30 degrees. Pi by 6, just unitary method. If you are thinking, sir, how you arrived at this equation, nothing, unitary method. Okay, that for t second the angle covered is 2 pi, in any time t second what is the angle covered. Unitary method, if you use simple unitary method, you can arrive at this equation. Now we have to put this value over here. Okay, let me erase this. So we have to put this value of theta over here. So v into, what is cos 30? Cos 30 is root 3 by 2, and v value is 10 meter per second, plus sin theta. What is sin 30? Sin 30 is half, so it will be 5 into root 3 I cap plus j cap. Okay, 5 into root 3 I cap plus j cap, so option C is correct. The magnetic field at the center of a circular coil of radius capital R carrying current I is 64 times the magnetic field at a distance x on the axis from the center of a coil. Then the value of x is, so here we have a coil and here we have a magnetic field at the distance, at the center and at the distance. Okay, so what is the formula for magnetic field at the center? Magnetic field at the center, I just told you, it is mu naught by 2 I by R. This is the magnetic field at the center, and magnetic field at any distance x is given by mu naught by 2 I R square divided by x square plus R square to the power 3 by 2. You derive this multiple times. This formula is very important, and you have derived this formula multiple times. So remember these formulas is very helpful. Now it says that the center magnetic field is 64 times the magnetic field at some distance x. Obviously magnetic field is maximum at the center. Any point outside center it will always be less. That's why magnetic field at the center is 64 times the distance. Right, now we have to put these values. Mu naught by 2 I by R equals to 64 times mu naught by 2 I R square divided by x square plus R square to the power 3 by 2. So mu naught by 2 cancel, sorry, mu naught by 2 cancels, I cancels. Okay, now let's do the cross multiplication and let's see. X square plus r square to the power 3 by 2 equals to 64 r cube. Okay, so this comes over here, this goes over here, r into r square becomes r cube, right? And this comes over here, so that's why it is 3 by 2. Now what we will do, first we will use you will write this as 4r whole cube. 64 is r cube, right? 64 is 4 cube, right? 64 means 4 cube. So what is the reason behind that? We can take a cube root of both sides. So we get x square plus r square to the power half. So cube root means 1/3, multiply by 1/3 on both sides in the power, right? So this is how you get. Now you square both sides. If you square both sides, now you get x square plus r square equals to 16r. Okay, 16r square, sorry, 16r square, right? Now from there we get x square equals to 16r square minus r square equals to 15r square, or x equals to square root of 15r. Okay, x equals to square root of 15r, which is option D. Next question. The torque acting on a magnetic dipole placed in an uniform magnetic field is 0 when the angle between the dipole axis and the magnetic field is. Torque acting on a magnetic dipole is mb sin theta. Okay, it will be 0 if m and b are not 0, then it is only possible when sin theta is 0, that is theta equals to 0. Okay, theta equals to 0 degree, that is option D. A proton and an alpha particle moving with the same velocity enter a uniform magnetic field with their velocities perpendicular to the magnetic field. The ratio of radii of their circular path is. So radii formula is given by mv by qb. Now in this given question, v and b are same. V and b are same, only thing that changes is the mass and charge. Now for proton, for a single proton, mass say mp, mass is mp. Okay, for proton, mass is mp, charge is plus e. Electron is minus e, proton is plus e. For alpha particle, you have to remember mass is 4 times that of proton. Okay, mass of alpha particle is approximately 4 times that of proton, and its charge is 2e. Okay, its charge is twice that of a proton. Okay, so what is the value of r proton? R proton is m proton v divided by charge into magnetic field. What about r alpha? R alpha is mass of alpha v divided by charge of alpha by b. Now mass of alpha is 4 mass of proton into v divided by twice e into b, or 2 mp v by eb, or twice rp. Okay, so alpha particle's radius is twice that of proton. Now let's see the question. Whenever this is a ratio based question, read the question twice to understand the order, which is very important to determine before answering. 1:2 can be the answer, 2:1 can be the answer based on the order. Same question can have different answers based on the order given to you in the question itself. So the ratio of radii of their circular path, there means, now let's check the order. A proton and alpha. So first is proton, next is alpha. So what we are trying to find? We are trying to find rp by r alpha, radius of proton by r alpha. Okay, so it will be rp by 2 rp, right? R alpha is twice of rp, so it will be 1 by 2, that is answer is 1:2. Answer will be 1:2, not 2:1. So after doing the simple mathematics, it might seem that okay, it might be 2:1, but if you read the order correctly, it will be 1:2 and not 2:1. So whenever you are solving a question which is related to ratio, make sure you are following the correct order, which is very, very important in case of ratio based question. A moving coil galvanometer is converted into an ammeter of range 0 to 5 milliampere. The galvanometer resistance is 90 ohm and the shunt resistance has a value of 10 ohm. If there are 50 divisions in the galvanometer turned ammeter on either sides of 0, its current sensitivity is. So before finding the current sensitivity, I just want to define what is current sensitivity. Current sensitivity is the maximum galvanometer current divided by the number of division. Total number of division. That's how you calculate the current sensitivity. Okay, now here you have to first calculate the Ig. Ig is not given. 5 milliampere is the maximum current you are measuring. It's a ammeter. So in case of ammeter, if you remember, I just did a small mathematics before. In case of ammeter, if this is I, this is the current that you are measuring. Some part of the current is passing through the galvanometer, remaining current is passing through the shunt. Okay, remaining current is passing through the shunt. Now if I is known, then we can calculate Ig using a simple formula, shunt divided by total resistance into Ig, into I, sorry. So Ig is basically given by S by G plus S into I. So what is S? S is 10 divided by 10 plus 90 into 5 milliampere. 5 milliampere means 5 into 10 to the power of minus 3. So what is Ig? Ig will be 10 by 100 into 5 into 10 to the power of minus 3, or it will be 1 0 will be cancelled and you will get 5 into 10 to the power of minus 4. Okay, so this is the current Ig. 5 into 10 to the power of minus 4 is the Ig. Now let's put these values. 5 into 10 to the power of minus 4. Sorry, one more mistake I made here. The sensitivity is not division by Ig by division, it will be division by Ig. Per division, how much current you are measuring. Per division, how much current you are measuring, that is the current sensitivity. Okay, and its unit is division per ampere. Its unit is division per ampere. So division is 50 divisions, and the current that you are measuring, the maximum current which is allowed is 5 into 10 to the power of minus 4. Okay, so 5 gives you 10 here, and you get 10 to the power of minus 4 in the division. That means it will go up 10 to the power of 5 division per ampere. 10 to the power of 5 division per ampere. That is option A is correct answer in this case. A metallic rod of mass per unit length 0.5 kg per meter is lying horizontally on a smooth inclined plane which makes an angle 30 degrees with the horizontal. A magnetic field of strength 0.25 Tesla is acting on it in the vertical direction. When a current I is flowing through it, the rod is not allowed to slide down. The quantity of the current required to keep this rod stationary. Now this question is partly incomplete because the diagram is not given. How the rod is kept in the incline is not given. That is why I feel this question is partly incomplete. So here is the rod. The rod is lying this way, not this way. Okay, the rod is lying in the horizontal way. Okay, so this is the horizontal way, this is the vertical way, vertical with angle with vertical, right? So this is how the this question could have been a lot easier if the diagram is provided. So this is the three-dimensional figure. You are using a cross section of this, right? The rod is carrying current, say, into the page of the paper, okay, or out of the paper, does not matter. So this is the rod which is placed like this, and this is the incline. You have to find how much current you should pass through it so that it does not fall. Now how it can fall? So there is a weight of this rod mg, and there is a component of mg which is mg sin theta. Now no friction is here, remember. Okay, so mg sin theta is acting downward. This is always the case, right? Now if this is the mg sin theta, this will try to take this rod in the downward direction. So we need some force in the upward direction to balance it out. Now which force will balance it over here? So there is one force which is BIL. Now BIL sin theta is the formula, but here in this case the angle between L and I is 90 degrees. So that's why there will be no sin theta here. So BIL is the force in this direction. So we can take a component of this BIL force in this particular direction, and that component will balance this mg sin theta. Now what is this component? So if this is BIL, this angle is theta, this angle is theta. Okay, so this is the similar angle, right? So it will be equal. So it will be BIL cos theta. This is adjacent, that's why it is cos theta component. Now don't confuse this with normal BIL sin theta formula. Okay, this BIL cos theta is coming because BIL is in this direction. To take a component in the direction parallel to the plane of the incline, we have to take BIL cos theta component. This is little tricky question. Okay, even with the diagram is given, this is one of the difficult question coming from this chapter. Okay, there was one more question which was wrong. I am not discussing that question. In 2022 paper, I think the paper was slightly difficult. In fact, all the subject questions was slightly difficult in this year. Now, what we have to do? We have to compare mg sin theta equals to BIL cos theta. Okay, now let us put the values. Now here length, mass per unit length is given. We are trying to find this I. So from here we can say that I equals to m by L. I am writing it separately. Why? Because mass per unit length is provided. So this L is coming to the division, and m by L I am writing over here. G by B. Okay, G is here, B coming to the division, into sin theta by cos theta. Okay, now let us put the values. So sin theta by cos theta is tan theta. So tan 30 we can directly put the value, which is 1 by root 3. So first we have to put the value m by L. M by L is 0.5 kg. So I equals to 0.5 into G value for now take 10. Okay, divided by 0.25. Divided by 0.25. Okay, divided by 0.25. Magnetic field is 0.25 Tesla. Okay, into 1 by root 3. Why 1 by root 3? Sin theta by cos theta is basically tan theta, and tan 30 is basically 1 by root 3. Tan 60 is only root 3. Tan 30 is 1 by root 3. Now simplify this. So 0.25, 0.5 we get 2. So 20 by root 3. Root 3 means 1.7. Okay, it will be very close to, if this value is close to 2, you can take this 10, but it is not 10, it will be 11 point something. Okay, you can simplify this, it will be 11 point something. Obviously you can 20 by 1.7 means answer is more than 10, right? Either it will be 14 or it will be 11. Okay, so you can check that calculation once and you will get the answer to be 11.32 and not 14.7. If the this is root 2, if it is root 2, then this would have been 14.76. A galvanometer of resistance 50 ohm is connected to a battery of 3 volt along with a resistance of 2950 ohm in series. A full deflection of 30 divisions is obtained in the galvanometer. In order to reduce the deflection to 20 divisions, the resistance in series will be. So we have solved this question in my lecture. Now let us solve this once more. Here we have a galvanometer, we have a resistance. Okay. Now the value of galvanometer resistance is 50 and the series resistance is 2950. right? What is the total resistance? Total resistance is 3000. Okay, now what is the voltage? Maximum volt we are measuring, maximum volt we are measuring 3 volt. So maximum volt we are measuring 3 volt means what is the galvanometer current? Galvanometer current is the voltage divided by the resistance, V by R, right? So it will be 1 milliampere. Okay, 1 milliampere. 3 by 3000 means 1 by 1000, which is 1 milliampere. Now that is giving you 30 divisions of deflection. 30 divisions of deflection. Now you want to increase this resistance so that this goes down to 20 divisions. Now remember that the Ig, the maximum value of Ig is constant. So what you have to do, you have to reduce the value of Ig which is passing at that particular moment so that the deflection reduces. So what will be the new Ig? The new Ig will be the whatever Ig that you had into the number of deflection that you are expecting, the number of divisions you have. So it will be 2 by 3 milliampere or 2 by 3 into 10 to the power of minus 3 ampere. Okay, Ig is 1 milliampere, that's why 2 by 3 milliampere. Okay, 1 multiply, but just multiply by 1 milliampere, that's it, right? So Ig dash we have calculated. Now we will again go back to the same formula. Ig dash is, the voltage is same, the resistance is changed. Resistance is changed. Okay, we have to find this resistance first. So Ig dash is 2 by 3 into 10 to the power of minus 3, which is 3 by R dash. So R dash is 9 by 2 into 10 to the power of 3. Okay, just cross multiplication, 4.5, so it will be 4500 ohm. Now this is the total resistance. Total resistance includes the galvanometer resistance plus the external resistance, right? So what is the resistance of the series resistance, external series resistance? That will be 4500 minus the galvanometer resistance. This is total resistance, that includes galvanometer resistance as well as resistance externally connected. So it will be 4450 ohm. In case you have any difficulty, don't forget to mention that in the comment below. Sir, I did not understand that question or this part. Please explain. I will do that explanation once more. No worries. Also, if you want to download this PDF, don't forget to join our WhatsApp channel. The link for the PDF will be exclusively shared in our WhatsApp channel. And also, if you have not yet subscribed, definitely don't forget to subscribe to our channel as well. A circular coil of wire of radius small r has n turns and carries a current I. The magnetic induction B at the point on the axis of the coil at a distance √3r from its center is. So this is the same problem. Okay, we have a coil and we are trying to find magnetic field at some distance x. So what is the formula for magnetic field? Formula for magnetic field is mu naught by 2, okay, IR square divided by R square plus x square to the power 3 by 2. Now here R is given by small r and x is given by √3 small r. Okay, at the center, what is the magnetic field? Okay, so we are trying to directly find the magnetic field. Now here there will be an Ni. Why Ni? Because the number of turns in this coil, this is not a single coil, it has n number of turns, so you have to multiply that n over here. That's it. Now put the value. So B equals to mu naught by 2 Ni small r square divided by small r square plus x square. So what is x square? X square will be 3r square, right? 3r square. So it will be 3r square to the power 3 by 2. So it will be mu naught by 2 Ni r square divided by r square plus 3r square is 4r square. 4r square power half. 4r square to the power 3 by 2. What is this? I can write this as 4r square to the power half whole to the power cube. Now what is this? Square root, basically square root means 2r, right? So 2r whole cube, right? So this is 2r and there is one cube over here, so we have to add that over here. So from there we can write b equals to mu naught by 2 I r square divided by 8r cube. So you can see that r square and r cube cancels and you get mu naught I by 16r. Mu naught I by 16r. There was one n over here, I missed the n over here. Okay, there is one more n. So mu naught ni by 16r, option A is correct. Now next question. A proton moves with a velocity of 5 into 10 to the power of 6 j cap meter per second through the uniform electric field E equals to 4 into 6 into 10 to the power of 6 times 2 I cap into plus 0.2 j cap plus 0.1 k cap volt per meter, and the uniform magnetic field B is given by 0.2 I cap plus 0.2 j cap plus k cap, the approximate net force acting on the proton. So I have solved this question in my lecture. So F equals to Q into E plus V cross B. E plus V cross B. Right? Now you have to first find V cross B. I will not solve the question completely. I will leave it because I have solved this question in my lecture. So in case you don't understand, you can go and check my lecture where I have solved this question in the second lecture. Sorry, it is solved in the first lecture, like part 1. Okay, so first we have to find V cross B. So I will help you, don't worry. I will not solve the question in detail. I will not tell you the answer. That is part of you to figure it out and mention the answer in the comment section below, so that I will know that you have seen up to this point. Okay, so V cross B, what is V? V is given by 5 into 10 to the power of 6 j cap meter per second. Now here if you see that okay, 5 into 10 to the power of 6 let us multiply it. So I cap, j cap, k cap. Okay, now there is no I component, so I is 0, only one j component, 5 into 10 to the power of 6, and there is no k component, so it will be again 0. Okay, and B will be, if you multiply everything, 0.2, 0.04 and 0.2. 0.2 into 1 is 1, 0.2, 0.2 into 0.2 is 0.04, and like that. Now for simplicity, what we will do, we will simply apply one determinant formula, that because only this number is here, so you can take this as common, and also we can take whatever common is here, that is 0.2, right? So we get I cap, j cap, k cap, and we can write 0, 1, 0, 1.2, 1, right? We can do that. Now we have to use the cross multiplication determinant principle. V cross B equals to, now 5 into 0.2 is 1, so 1 into 10 to the power of 6 is 10 to the power of 6, and we will just break the determinant. If you don't know the determinant method of cross multiplication, then this is a good exercise for you. So first I cap, 0 into 0.2 minus 1 into 1. So sorry, I will be covered, right? So I will be covered. So 1 into 1 minus 0 into 0.2, that is 1. Okay, so determinant, first we are doing for I cap, so this and this will be covered, right? So 1 into 1 is 1, 1 into 1 is 1, minus 0.2 into 0, which is 0. Right? Next is, now if you are using plus convention, that is fine. If you are using minus convention, which that is also fine. Whatever convention that you have learned, that is no problem, but use the same convention always. Okay, I use plus convention, I am comfortable with plus convention. Okay, so now we will start with J cap. So J, this one and this one will be covered. So 0 into 1, right? 1 into 1, 2 into 0.2 into 0, so 0 into 1, 0, sorry, J cap, right? Zero into 1 is 0, 1 into 0 is 0, so J cap, everything will be 0, plus K cap. Now in case of K cap, again now we will cover this. 0 into 0.2 is 0, minus 1 into 1 is 1. So done. So it will be 10 to the power of 6 I cap minus K cap. Okay, so this is the value of V cross B. Okay, this is the value of V cross B, and Q is given as proton. So charge of proton is Q, you have to put the value. Q is 1.6 into 10 to the power of minus 19. Now E value is given over here. Now you have to add, they are vectors, so they will be simply added as vectors, right? Now remember that here we have 10 to the power of 6, whereas here we have 4 into 10 to the power of 6. So you have to take 10 to the power of 6 as common, not 4 into 10 to the power of 6. 4 will be multiplied with E. Okay, so 10 to the power of 6 will be common, and you get 4 into 2, 8 I cap. Okay, 4 into 0.2, 0.8 J cap, plus 4 into 0.1, 0.4 K cap. Now here we have plus I cap minus K cap. Okay, so just simplify it. Okay, so this is the force. So force will be given by, just add, in case of this type of vector addition, I and I will be added, right? So 1.6 into 10 to the power of minus 13. Okay, 1 and 8, 1 plus 8, 9 I cap. There is no J cap, so 0.8 J cap, and minus 0.6 K cap. Now there was one shortcut, I taught you how to do that. Okay, you can calculate it and you can find the exact value in this particular case. Okay, now you can guess even the answer from this this much calculation. You are about to find the approximate value, so you can even guess the approximate value after calculating this much. But this is a long question, not super easy in terms of length, conceptually easy, but mathematically little long. Let's see next question. A solenoid of length 50 centimeter having 100 turns carries a current of 2.5 ampere. The magnetic field at one end of this solenoid is, again this question also I have solved it. Here we have a solenoid and they ask you what will be the magnetic field at the end. So there is a unique trick for that. We will find the magnetic field at the center. Okay, and then we will, for the end, it is magnetic field at the center divided by 2. This is how we will find. So what is the magnetic field formula? Magnetic field formula is mu naught Ni. Here N is the number of turns per unit length. Okay, 50 centimeter is the length, total number of turns is 100 turns. Okay, so number of turns will be 100 divided by 50 centimeter. Centimeter to meter you have to convert always. Okay, meter to centimeter, centimeter to meter is compulsory, so it will be 200. So number of turns is 200 per meter. Okay, always SI unit, always SI unit. Mu naught is 4 pi into 10 to the power of minus 7, N is 200 and current is 2.5. Okay, now let's multiply. 4 into 2.5 is 10. So 10 into pi, so 2000 pi into 10 to the power of minus 7, or 2 pi into 10 to the power of minus 4. Now pi is 3.14 into 10 to the power of minus 4, so it will be 6.28 into 10 to the power of minus 4. 6.28 into 10 to the power of minus 4. Correct answer option D. This is an easy question. Next, a strong magnetic field is applied on a stationary electron. Then the electron moves in the direction of the field, moves in the opposite direction of the field, remains stationary, starts spinning. So remember that magnetic force acts on a charge which is moving. Magnetic force does not act on a stationary charge. So if the charge remains stationary at the beginning, it will remain stationary even if you apply the strongest possible magnetic force, magnetic field. Okay, because it is V cross B. So V is 0 means the magnetic force will 0. If the magnetic force is 0, that means the charge will remain stationary. Two parallel wires in free space are 10 centimeter apart and each carries a current of 10 ampere in the same direction. The force exerted by one wire on the other. So we have to find the force exerted on one wire due to one wire on the other, which is given by, let's see, force is mu naught by 2 I1 I2 by D, 2 pi, mu naught by 2 pi I1 I2 by D. This is the force per unit length, right? Or force per unit length is 4 pi into 10 to the power of minus 7 divided by 2 pi. Okay, now it is said that the current is 10 ampere each and the distance is 10 centimeter. Again, centimeter to meter is compulsory. So 10 cancels and you get 2 into 10 to the power of minus 7 into 10 to the power of 3. Here we have 1, this goes up, gets added, so becomes 10 to the power of 3. So 2 into 10 to the power of minus 4. So 2 into 10 to the power of minus 4. Now whether it will be attractive or repulsive depends on the direction of charges. Okay, same direction means attractive, so it will be 2 into 10 to the power of 4 attractive. So correct answer is option A. A tightly wound long solenoid has n number of turns per unit length, a radius r and carries a current I. A particle having charge small q and mass small m is projected from a point on the axis in a direction perpendicular to the axis. The maximum speed of the particle for which the particle does not strike the solenoid. So here we have a solenoid. Okay, we have the radius is given by small r. You are projecting one particle like this such that it will rotate here. Okay, so if this is the rotation, because magnetic field lines are there, so you are launching a projectile in this direction from the center, right? So it has to contain himself within this r by 2 radius, okay, such that it does not touch the solenoid. Okay, if it is more than r by 2, then it will touch the solenoid. This is the basic problem. Otherwise it's a simple magnetic field and magnetic force question. Okay, so you have to understand that the radius is r by 2. Okay, and what is the value of magnetic field inside a solenoid? Mu naught Ni. This is the formula for magnetic field, right? Now they ask you what is the maximum velocity. Now you have to use this formula, R is equal to mv by qb. mv by qb, this formula you have to use. From here you can find the velocity, which is qbr divided by m. QBR divided by m. Right? Now let us put the values one by one. So Q is Q. Okay. Magnetic field B is mu naught Ni. Radius in this case is r by 2 because this is the maximum radius. M is m. So it will be mu naught Ni QR divided by 2m. So mu naught Ni QR by 2m. So correct answer option B. Okay. The magnetic field at the origin due to a current element dl placed at a point with the vector position r vector is. So I have solved and discussed this in my lecture. If you are using r vector, it will be mu naught I by 4 pi r cross dl by r cube, because this one of the r's magnitude wise will cancel, but the direction it will stay. So it will be sorry, this is the correct answer, dl cross r, not r cross dl, sorry. Okay, this is the correct answer, dl cross r. You have to remember that one of the r will be cancelled, so that you get the magnitude wise it is still r square, but because you have written r vector in the numerator, you have to adjust the denominator and add r cube. If you have written this in terms of r cap, then this would have been square. In the given figure, magnetic field at O. So let us understand this. Again, I solve this in my lecture time as well, but I will solve it. This is an important question, so I will solve it again. So here we have a circular coil. Okay, so if it is a complete circle, nothing else is there, what is the magnetic field? So the magnetic field at the center of a circular coil is given by, we have solved it multiple times, so by far you should have remembered it, mu naught by 2 I by radius r. This is for complete circle. Okay, now here if you see that if you can divide the circle into how many parts? 1 part, 2 part, 3 part, 4 part. This is the magnetic field due to all 4 such parts, but this part in this particular problem is missing. So only 3 parts are there. So for total 4 parts, this is the magnetic field. So for 3 of them, the magnetic field will be 3 by 4. Okay, for total 4 parts, this is the magnetic field, but we have present only 3. So using unitary method, for 4 parts the magnetic field is this, for 1 part magnetic field is 1/4 of that, for 3 parts magnetic field will be 3 times, right? So it will be mu naught I by 3 mu naught I by 8 r. I think radius is given is smaller, so smaller. Okay, even though it is clear here, it is given radius is given smaller. This is the arrow, this is the arrow. Now this is not over yet, this is not over yet. What else you have to do? You have to consider there are two more current carrying wires. One wire carrying current in this direction, one wire carrying current in this particular direction. Okay, now if you consider this wire and the point that we are trying to measure the magnetic field, which is center, so this wire is carrying current passing through the center itself. So in this case there will be no magnetic field due to this wire at center, because it is passing directly through the point, right? But this wire carrying current, it is not passing through the center, it is at a distance. So there will be a magnetic field due to a current carrying wire. Now for an infinitely long current carrying wire, the magnetic field is given by B equals to mu naught by 2 pi I by r. Okay, this is the magnetic field due to an infinitely long current carrying wire. But here this is infinite on right hand side or in this side, okay, but it is not infinite in that side. On the left hand side it is not infinite, on the right hand side it is infinite. So again we can say that it is basically an infinite wire, but somehow we have cut it from the middle. So the infinity is still left on this side, this half is missing. So magnetic field due to this infinite wire will be just half of that. Okay, so this is the circular coil, this is the straight wire. So total magnetic field is basically given by 3 mu naught I by 8r plus mu naught I by 4 pi r, mu naught I by 4 pi r. Okay, now you might ask me, sir, why it is plus? It could be minus as well. So for that you have to use right hand rule separately. For a circular current carrying wire, the magnetic field, first you have to curl your fingers, then your thumb will point in the direction of the, so if you curl your fingers, your thumb will point in the direction of the magnetic field. So in this case it is into the page of the paper. For a straight current carrying wire, okay, you first align your thumb in the direction of current, then curl your fingers, that will give you the direction of current again into the page of the paper. So both cases, this case as well as this case, both are basically in the same direction, that's why it is getting added. So the correct answer is 3 by 8 mu naught I by r plus mu naught I by 4 pi r. So option A is correct. A long cylindrical wire of radius capital R carries a uniform current I flowing through it. The variation of magnetic field with the distance small r from the axis of the wire is shown by. So here we have a cylindrical wire. Okay, cylindrical wire, how the magnetic field will change. So outside the wire magnetic field will be 1 by r. We know that, right? Mu naught by 2 pi I by r. So outside the wire it is 1 by r. But what about inside? Is there any magnetic field inside? Yes. So magnetic field at the center is 0 and it slowly increases, then it decreases with 1 by r. Okay, now unfortunately this graph and this graph are almost same, no such difference. Okay, now this can be proven, okay, using Ampere circuit law. You can consider the current density J and you can derive it. If you want this derivation, I can do it in a separate video. Okay, but both of them appears to be same. I am not sure, either it was misplaced, any one of them can be answered. Okay, if you mark option A or option B does not matter. If this is the question, then definitely it would have been a bonus question. The number of turns in a coil of galvanometer is tripled. Then both voltage and current resistivity remains constant. Voltage sensitivity increases 3 times, current sensitivity remains constant. Both voltage and current sensitivity decreases by 33%. Voltage sensitivity remains constant and current sensitivity increases 3 times. Now if you have followed my lecture, current sensitivity is proportional to number of turns. Okay, so if you increase the number of turns 3 times, then current sensitivity increases 3 times. Okay, but voltage sensitivity is independent of number of turns because it has N by R. So if you increase number of turns, that is you are increasing the length of the wire. If you increase the length, the resistance will also proportionally increase. Exactly, if you double the length, resistance will be doubled. If you triple the length, resistance will be tripled. So it will cancel. So voltage sensitivity is independent of number of turns. So voltage sensitivity will remain constant, but current sensitivity will be tripled. Okay. A circular current loop of magnetic moment capital M is in an arbitrary orientation in an external uniform magnetic field. The work done to rotate the loop by 30 degrees about an axis perpendicular to its plane. So here we have a current carrying loop. Okay, and it is an arbitrary direction. but the magnetic field is in the perpendicular direction, right? But if you rotate it in this direction theta, okay, the initial work done and final work done will remain same, no change. So that's why the work done requires to rotate the around this axis will remain 0. Okay, if you are rotating in like this, then there will be some work done based on the angle, but in this case the work done will be 0. The magnetic field at the center O in the given figure is, so magnetic field at the center O in this given field. This is a similar question. Okay, in the previous case the angle was 90 degrees. Okay, if you remember, the angle was 90 degrees and there was some current carrying wire also. But here the angle is not 90 degrees, here the angle is 60 degrees. So slightly same policy, but slightly same different approach. Okay, so if it is 90 degree, we could have said, okay, 1, 2, 3 part were there, so 3/4 would have been the answer. But here only 60 degrees is here. So how to tackle this? So for that we have to go back to the total angle. So what is the total angle? Total angle is 360 degrees. Okay, and how much wire we have here? What is this angle? So total angle is 360 degrees, 60 degrees out. So how much angle is included? Included angle is 300 degrees. That's it. 360 minus 60, that is 300 is included. So you have to find the magnetic field due to this 300 degree angle. So what is the magnetic field, by the way? Formula mu naught by 2 I by R, and this is for total 360 degree angle. Okay, so for 360 degree angle the magnetic field is mu naught by 2 I by R. So what is the magnetic field due to 1 degree angle? It will be mu naught by 2 I by R into 1 by 360. So what is the magnetic field due to 300 degrees? So it will be mu naught by 2 I by R 300 by 360. Problems not always difficult. Okay, you might be feeling confused about such questions at times. 5 6 ja 30, 6 6 ja 36. So it will be, so the magnetic field will be 5 mu naught I by 12 R. Okay, simply unitary method problem. Okay, so 5 mu naught I by 12 R. Option D is correct. Simple unitary method problem. So even though the question looks tricky, it was not actually that tricky. The correct Biot-Savart's law in vector form is, so this is again, this is a repeated question. So it is I dl cross R, divided by R cube, because you are writing it in vector form. So I dl cross R divided by R cube. An electron is moving in a circular radius R in an uniform magnetic field B. Suddenly the field is reduced by B by 2. The radius of the circular path now becomes, now let's see what is the formula. So radius is mv by qb. This is the old radius. Now what you have done, you have reduced the magnetic field by B by 2. So new magnetic field is B by 2. So m is same, velocity remains same, the charge remains same, but the magnetic field becomes half, right? So it will be 2 of mv by qb. Okay, this goes up, so that is 2 into r. Okay, so r dash is basically 2r, so the new radius will be 2r. A charge q is accelerated through a potential difference v. It is then passed normally through a uniform magnetic field where it moves in a circle of radius r. The potential difference required to move it in a radius of 2r is. So very interesting question. Okay, so everything remains same. First, what is the, it is passed through a magnetic field. What is the radius? Radius is mv by qb. Now charge remains same, magnetic field remains same, charge remains same, means mass is same. So only thing which is changing is v. So the here you have to know a small fact, that exact thing you will learn a little bit further ahead, dual nature of radiation and matter. In photoelectric effect you will learn about it, that when you pass a charge through a potential difference V, what is the kinetic energy of that particle? The kinetic energy, the potential energy, we know potential energy is Q into E, and in fact the kinetic energy will also be the same value. Okay, so the kinetic energy half mv square will also be the same, so it will be Q into E, U into V. Okay, so this is the thing. From here you have to calculate the velocity V, which is 2q velocity V divided by m square root. Okay, so if you put that, we will know that radius is directly proportional to square of the voltage. If you put that, because it is in the numerator, so numerator means, and this is also in numerator, so numerator you will be added up, so radius is directly proportional to the applied voltage difference. Okay, so for voltage V it has a radius smaller. For another radius, so R by 2R will be equals to initial voltage divided by the final voltage. Okay, so R cancels, and you get, if you square them, 1 by 4 equals to V by V dash, or V dash equals to 4V. So you need 4 times more voltage. You need 4 times more voltage. Last question. A straight wire of length 550 centimeter carrying a current 2.5 ampere is suspended in mid-air by uniform magnetic field of 0.5 Tesla. The mass of the wire is. So here we have a wire, okay, length 50 centimeter, carrying a current 2.5 ampere. Okay, so current is 2.5 ampere. It is hanging in the mid-air by magnetic field of 0.5 Tesla. So what is the mass? So from here, this is basically mg, and this is the magnetic force. So what is the magnetic force in a current carrying wire? Magnetic force in a current carrying wire is BIL. Okay, sin theta is there, but in this case this is perpendicular, so sin theta is 1. So magnetic field is 0.5 Tesla, current is 2.5 ampere, length is 50 centimeter, that is 50 into 10 to the power of minus 2. Okay, don't forget to convert it. Okay, so it will be 5 5 is 25, 25 62.5 into 10 to the power of minus 2. This is the magnetic force. Okay, how I calculated it, you can skip this part if you are interested. Let me not complicate that thing, we will do that in a while. 0.5 into 50 is 25. Okay, into 2.5 into 10 to the power of minus 2. So this is the magnetic force. Now what is this magnetic force is balancing? It is balancing the weight of the wire. So 25 into 2.5 into 10 to the power of minus 2 is nothing but mg. Now what is mass? We don't know. G we are assuming 10. Okay, from here we can say that mass is basically given by now 25 into 25 is 625. So 25 into 2.5 will be 62.5. That's how I was written that value over here. Into 10 to the power of minus 2 divided by 10. This will come division, right? Cross product, so it will be minus 3. Now this will be in kilograms. Everything is SI, so it will be in kilograms. So from there we can write it will be 62.5 grams. Okay, 62.5 grams. So option C is correct, right? And with this note I would like to end this lecture. I will be back with more videos very soon, and if you want to feature in one of our toppers list, then you have to follow all of our lecture regularly, and also the questions that I am asking you have to answer them regularly, right? So don't lose your focus, and obviously follow our channel and subscribe to our channel. I will be back. Till then, bye.